Good morning, Algebra 1 CP students. This is a lesson for April 28th for my B-Day students and April 29th for my A-Day students. In this lesson, we are going to practice, we're going to learn how to find the greatest common factor, but not of just numbers, the greatest common factor of algebraic terms or of monomials. All right, so before we begin, let's review the vocabulary related to factors and common factors. If we consider two numbers, and again, this is a learning environment, right? These are just used as an example. So let's consider two numbers, 16 and 72. The factors of 16 are, they're all the numbers that you can divide into 16 without a remainder. So 1, 2, 4, 8, and 16, right? The factors of 72 are all the numbers that you can divide into 72 without a remainder. So 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Now let's look for common factors. To have something in common means to have something that is the same, right? If you have a favorite movie in common, it means with someone else, it means you and someone else have the same movie as a favorite movie. So common factors are 1, 2, 4, and 8. So common factors of 16 and 72 are 1, 2, 4, and 8. Now, what we need sometimes in calculations is not just to find the factors two or more numbers have in common, but the greatest common factor two or more numbers have in common. Greatest meaning the biggest, right? Great means big. So the greatest common factor of 16 and 72 is, of the four numbers, the largest number is 8, so it's going to be 8, okay? All right, so that's a common factor, and let's do a problem where we are asked to find the greatest common factor of two numbers. Find the greatest common factor of 125 and 600. The way I'm going to do this is not the way we just did it, where we just listed all the factors. What I'm going to do is I'm going to use prime factorization in order to divide each number into a product of its primes. So let's do the prime factorization tree. So step 1, write 125 and 600 as a product of prime factors. So let's do a prime factorization tree. 125 is divisible by 5. You're left with 25, and then it's divisible by 5 again, and you're left with 5 and 5. So 125 equals 5 times 5 times 5. And 600 is divisible by 2, that leaves you with 300, divisible by 2, which leaves you with 150, divisible by 2 again, which leaves you with 75, divisible by 3, 7 plus 5 is 12. Remember, numbers whose digits add up to a multiple of 3 are divisible by 3. So you get 3 and 25, and you get 5 and 5. So 600 is 2 times 2 times 2 times 3 times 5 times 5. So to find the greatest common factor, multiply the common factors. So the greatest common factor equals, the common factors are, well, first of all, you have a 5, right? You have a 1 5 in common, and then you have another 5 in common. So I'm going to multiply 5 times 5. So the greatest common factor is 25. That's it. So the greatest common factor of 125 and 600 is 25. All right, let's do that again. Problem 2, find the greatest common factor of 143, 26, and 130. But I'm not gonna do the factoring trees for this one. You can do this on the side to confirm the answer. So step 1, write 143, 26, and 130 as a product of prime factors. 143 equals 11 times 13. 26 equals 2 times 13. And 130 equals 2 times 5, 10 times 13, right? So 2 times 5 times 13. Step 2, find the greatest common factor by multiplying the common factors. So the greatest common factor is, the common factor they have is 13. There are no other common factors they have. 26 and 130 have a factor of 2 in common, but we're finding the greatest common factor of all three numbers, so all three would have to have them in common. So the greatest common factor of 143, 26, and 130 is just 13. All right. Now, we're going to move on to the new stuff. Find the greatest common factor of 125 x to the fourth and 600 x to the second, or x squared. We know how to find the greatest common factor of two numbers. How do you find the greatest common factor of two terms or two monomials? Well, you do it the same way. So you begin by writing 125 x to the fourth and 600 x squared as a product of prime factors. So in order to write 125 x to the fourth as a product of prime factors, I'm going to write the prime factorization of 125, which is 5 times 5 times 5, times the prime factorization of x to the fourth. Now, what is the prime factorization of x to the fourth? Well, I don't know what x is, so it's kind of tricky for me to know how far it breaks down, but I do know that at least it's x times x times x times x, right? So that's the prime factorization of 125 times x to the fourth. The prime factorization of 600 times x squared is the prime factorization of 600, or 2 times 2 times 2 times 3 times 5 times the prime factorization of x squared, or x times x. So now you're ready to find the greatest common factor by multiplying the common factors. So the greatest common factor is, you got 5 in common to both. You have another 5, so times 5. You have an x that's in common to both, and then another x. So you get 5 times x, or 25x squared. So the greatest common factor of 125x to the fourth and 600x squared is 25x squared. All right, we can try that again. Problem 4, find the greatest common factor of 143y cubed, 27y squared, and 130y. Step 1, first write those three terms as a product of prime factors each. So 143y cubed, 143 is 11 times 13, y cubed is y times y times y. 26y squared, 26 is 2 times 13, y squared is y times y. 130y is 2 times 5 times 13 times y. So find the greatest common factor by multiplying the common factors. The greatest common factor is they have a 13 in common. So 13 times they have a y in common, times y. Notice the first two terms do have more things in common. They have another y in common, but it has to be common to all three terms. So all I have is, so the greatest common factor of 143y cubed, 26y squared, and 130y is just 13y. All right, I have a few more of this type. Problem 5, find the greatest common factors of 8y squared, 2y, and 14. Well, step 1 is to rewrite those terms as a product of prime factors. 8y squared is, 8 is 2 times 2 times 2 times y times y. 2y is 2 times y, and 14 is 2 times 7. So the greatest common factor is the product of their common factors. So the greatest common factor, they have a 2 in common, and then they really don't have any other numbers or variables in common. So the greatest common factor of 8y squared, 24y, and 14 is 2. Right? Problem 6. The greatest common factor of 18xy squared, 2x cubed y squared, and 100x cubed y cubed. So the first thing I'm going to do is write those terms as a product of primes. So 8xy squared is 2 times 2 times 2 times x times y times y. 2x cubed y squared is 2 times x times x times x times y times y. And then 100x cubed y cubed is 2 times 2 times 5 times 5 times x times x times x times y times y times y. So to find the greatest common factor, multiply the common factors. So all three terms have a factor of 2 in common, times all three have a factor of x in common, times all three have a factor of y in common, times all three have another factor of y in common. So the greatest common factor is 2 times x times y squared, or 2xy squared. I'm going to just state our results. All right, now you're ready to try a few problems on your own. just looking for greatest common factors. We're just going to practice that skill before we move on. All right. And the problem set is online, and you guys have been doing a great job submitting them through Schoology. I'm grading them as you're submitting them. Make sure you read my comments, because a lot of this, we're building on the material. So if you're making mistakes, you're probably going to make them again. Just make sure you read my comments on the graded assignments. Have a wonderful day.